Welcome back. In this video, we're going to talk about, again, using linear programming to perform an optimization. However, in this optimization, we're going to switch things around and we're going to look at a minimization. And at the end of this discussion, we're going to speak to the sensitivity analysis that comes out of the solution. So the example that we're using is example 17.3 from the Jaggia et al. Business Analytics textbook. You'll find that in your, again, in your textbook. You also have a file that is called chai.xls. Whenever you open it up, the purpose of this file, once again, is just to make sure that you have a standard place to start from. Step A tells us that you need to go ahead and put the information in from the example for the chai, and from this example for the Yerba Buena Tea Company, they have three different facilities: an older facility, a newer facility, and a special facility where they make two products. One of them is a powder mix that all three can do. The second is a tea concentrate, which only the older and the newer facilities can do, but the special facility can't do that. There's a cost associated with each of these. They are here. Similar to what we've done in the past, we've gone ahead and added just a starting point of 1, 1, and 1 in our decision variables. This will come in place later, but you'll go ahead and place ones in there for now. And then down here, you'll add the constraints of 5,500, 4,000, and 8. Now to getting the formulas in. The powder mix is the sum of products for what is produced by each of the three times what they can produce, okay? Similarly, the tea concentrate is the sum product of what is being made and how much can be made per hour. And then finally, the hours operated at the older facility is just the number of hours from the decision variable that is used whenever the optimization is done. Last step for you to do here is to go in and set up the objective function. What we're trying to minimize is the total cost. That is the number of hours times the cost per hour for each of the facilities. So that's a sum product that finishes up here. Everything is now loaded, and if you go to Data and Solver, Data and Solver, set objective function again is F4. That's the objective function. This is a minimization. We are going to change these three cells. Add your constraints. Remember, you can do an add and make sure that you get the directional greater than or equal and less than or equal to add these. So you'll add each of the three constraints just like you have before. We want to make sure that it's non-negative. We're once again going to use a simplex LP. And this time whenever we solve, we want to make sure that we have answer and sensitivity checked, because I want you to look specifically at these. You click OK. It says the way that we will minimize the total cost to meet our current demand of 5,500 and 4,000 is the older facility is going to do 8 hours, the newer facility does 5.12 hours, and the special facility does 3.34. Okay, again, that shows up in our answer report. Answer report comes in and says, here's the final value, here are the answers for what we're going to do. Also shows that whenever we go down and look at our constraints, that there's no slack at all in the constraints. Everything is maxed out, okay? We have used up every bit of the constraint that we can. So let's look at the sensitivity report. Sensitivity report is also listed in your textbook where it talks about how to interpret the sensitivity report. It's very important to us because whenever we do this optimization, one thing that we know is that for the older facility, that we're going to use up 8 hours, okay? We know that 8 hours is the maximum. So we have absolutely filled up the older facility. Also, it says, now what would happen from a sensitivity standpoint for us not to use up all 8 of those? From this, it says that we could go up $2.30 basically above what our current cost is, and we would still use all 8 hours of that. Okay, again, so we could go up to 192.30, and we still would use all 8 hours of it. If the cost there goes any higher, then it's going to start changing what we're going to use. Similarly, look at these areas here. Allowable decrease is saying that if we could find a way for that newer facility to reduce the cost by $3.31, which would take us from 260 down to 256.69. If we could find a way to decrease that cost, then we would start using more of this hours from the newer facility. Also, on the special plant, remember the special plant only makes 2 different items for us. It has this range of allowable increase or allowable decrease. So I'll let you fight through that and make your decision on the way that works, because on this assignment, one of the things that you will be getting evaluated on is 30 points of the 100 points is going to go back into your explanation of the solution. In the explanation of the solution, you need to talk about the final answer and the sensitivity of how things would have to change to make this no longer the optimal answer. All right, good luck, and let me know if you have any questions.